Dear friends, in this video I will be talking about linear system. When we say that particular system is linear, we know that if particular system follows superposition principle, in that case we can say that the system is linear. So in other words, if we are having system, we are applying one input and we are recording output corresponding to that input. Now remove that input, apply another input, record the output for that new input. Then take the linear combination of these two inputs, apply to the system. In that case, if the output of the system is linear combination of respective outputs for individual inputs, whatever inputs we have taken. So it is so simple to show that system is linear system. If we know system is linear, many mathematical issues, whenever we take into account this linearity property of the system, if system we say that it is linear system, then so many things gets clear, because linearity is one property and based on linearity so many solutions are there. So that is why one should study whether system is linear or not. So there are so many things which are proved already and that can be applied if system is linear. So whatever I said, that we'll see with the help of block diagram. So what I said, let us consider system represented by T, apply input x1n. Let us say output of the system to this input is y1n. Now take the same system, apply input x2n. I am changing the input and record the output. Let us say response, that is output of the system, is y2n. So response of the system to the input x1n is y1n and response of the system to the input x2n is y2n. So responses to the individual inputs are known to us. Response of the system is output of the system for that particular input. y2n is a response. It is a response to the input x2n. Okay, now we'll see that if we take the linear combination of these two inputs. So let us consider that x3n is another input which is linear combination of these two inputs x1n and x2n. So let us consider that x3n is the new input which is linear combination of input x1n and input x2n. So what is the response of the system to this input? Then in that case we can say that system is linear. If the response of the system to this input x3n is, let us say, after passing this x3n we got the output y3n. Okay, after applying input x3n we got the output y3n. So y3n is the response of the system to the input x3n. x3n is what? Linear combination of x1n and x2n. If this response y3n is equal to linear combinations of individual outputs to these inputs x1 and x2n, linear combination of outputs to the individual inputs x1n and x2n, then we can say that system is linear. What I am saying is, so response of the system to the input, let us write like this. This is empty and this it is read as response of the system to the input x3n is let us say y3n, we can write like this or you can write like this. So it is read as response of the system to the input x3n. If this y3n is equal to, linear combination of output. So if I am getting this y4n, let us say y4n is the output which is linear combination of outputs to the individual inputs. So it is a linear combination of outputs y1 and y2 for the input x1 and x2. So this y4n and this y3n, if they are matching, in that case we can say that that particular system is linear. And this x3n, you know, in particular this is nothing but linear combination of input. So linear combination of input, that is x3n, linear combination of input, response of the system to the linear combination of input is equal to linear combination of each of the output for these individual inputs. Then we can say that system is linear. So this can also be explained in a better fashion by another diagram, block diagram. So right now what I said is system which follows superposition principle, we can say that system is linear. Or in other words, if you want to show it is linear, then what you do, find the response of the system to two distinct inputs, x1n and x2n. Then take the linear combination of input x1n and x2n, where a and b, they are the coefficients of linear combination, they are the constants, they are scalars, they are constant. Okay, so linear combination of input, I am getting another input x3n, and response of the system to x3n, it means what? Response of the system to the linear combination of input, if it is equal to linear combination of outputs to the individual inputs, then we can say that system is linear. One more thing I would like to tell you, that here the system, linear system, is that system which follows that zero input, it gives zero output. So whenever we put your input is 0 for all n, input is 0 for all n, in that case output must be 0 for all instant n. Okay, let us see how that is true. So I am just whatever it was written, now that I will show you in the terms of block diagram. Say x1n is multiplied by a, x2n is multiplied by b, these are a and b, they are constant, and then what we get, we are adding these two, we are getting another input, that is we are saying x3n. x3n is the linear combination of input. So in x3n, so we are having x3n and we are passing that x3n through a system which is denoted by t and whose output is y3n, whose output is y3n. So this is linear combination of x1 x2. So this is the linear combination, and output of linear combination is given here, we have got y3n. Now what I am doing, I am taking what x1n I am passing through a system, x1n separately I am passing, and second case I am passing x2n again through a same system. See the change here. Here I first multiplied by a and b, added, and then I took the linear combination, and that linear combination is passed. But in this case I am passing input through the system, and individual output of the system is multiplied by a and b, and then those outputs they are added. So you know, this is y1n and this is y2n. So and here I am getting, let us say, y4n. So what I am saying, if y4n and y3n they are matching, then we can say that the given system is linear. So what I am doing is linear combination of input, that is x3n, response of the system, this is y3n. y3n is the response of the system to the input x3n. and here in this case I am taking responses of the system to the individual inputs y1, y2. They are the responses of the system to the input x1n and input x2n. So after getting these responses, I am multiplying these responses by a and b, and I am getting output y4n, where y3n and y4n, if they are matching, in that case we can say that the system is linear. System is satisfying the property of linearity. So we can also say that system is linear when 0 input produces 0 output. This is one of the requirement. 0 input implies 0 output. If this is not satisfied, system is not linear. Here what I said is system will be it will not be a this one candidate for linear system or satisfying the linearity property. It is not satisfying linearity property if you just test for x of n equal to 0. If x of n equal to 0, output is not 0, then we can say that straight away that system will not be a linear system. So this is one of the requirement. It is not completely saying that system, even if this condition is satisfied, what I mean to say is even if this condition is satisfied, we cannot say that system is linear. So let us take the example and see that whether given system is following linearity property or not. So let us consider that input is x of n, response of the system to the input y of n is e to the power x of n. So this is the exponential system. We know that by looking at the system, looking at the output, we can say that output of the system is exponential of input. So straight away we can say that system is not linear. It is not linear, right? So, or you can check for 0 input, x of n is 0. What I said, x of n equal to 0 for all n, signal should be 0. Signal should be 0 through and through, that is minus infinity to plus infinity. Right here y of n is 1. Y of n is 1. So x of n is 0 for all n, y of n is 1 for all n. So this is what we can say here. This itself tells you that the system is not linear. But I will explain you the procedure, complete procedure for say this one, verifying or saying the system is not linear by using whatever theory I have explained before this example. So let us find out the response of the system to the input. Let us consider response of the system to the input x1n. So input is x1n. We know that response will be e to the power x1n. So if input is x2n, we know that the response of the system will be e to the power x2n, right? So when I apply x1n, I will be getting e to the power x1n. If I apply x2n, I will be getting e to the power x2n. Now if I apply third input which is x3n, which I say a times x1n plus b times x2n, right? So e to the power x, the response y3n is equal to e to the power x3n, right? This is the response of the system when the input is x3n. So which is written as e to the power a x1n. Here it is plus, so I can write e to the power b x2n. So there is a addition of powers when base is same. So response of the system to the input x1 and x2, x1, x2 is known, and even response of the system for the input x3n is also available with us. Now our job is to write what is linear combination of output to the individual input. So let us say y4 is the response of the system to the linear combination of output a into y1n plus b into y2n, right? So a times y1n is nothing but response of the system to the input x1n, and b times y2n is the response of the system to the input x2n. So this is y4n. This is the output. This is the linear combination of outputs. Linear combination of output is not equal to response of the system to the linear combination of input. Hence system is not linear. System is not linear, so it is not a linear system. By observation also we can say that output is exponential of input. System cannot be linear. So this is the method by which we can show that system is whether it is linear or not. Here y3n, it is the response of the system to the linear combination of input, is not equal to linear combination of output. So hence the system, given system, is not linear. Now let us take simple example where we are only adding the inputs, n inputs, and we'll check whether that kind of system is basically it is an accumulator kind of system, right? So k equal to, let us say, minus infinity to n, and I am taking x of n minus k. So it is addition of all inputs up to the instant n. So what I am saying here is apply the input and see the output. So y1n is a response to the input x1n. So I can write directly. So x1n minus k is equal to minus infinity to plus infinity plus n. Again, response to the input x2n is y2n. So let us write x2n minus k. I am not writing those statements because you can take it from earlier example. So it is the response of the system to the input x2. If input is x2, you get this response. Input is x1, we get this response. If I take linear combination of this, let us say y4n, we are denoting linear combination of outputs. So linear combination of outputs a1 y1n plus, or I am taking only a and b, a y1n and b y2n, linear combination of output. If I see this is nothing but summation k equal to minus infinity to n, and y1 is nothing but y1, we know it is x1 of n minus k, plus b times, we know that it is x2 of n minus k. This is the linear combination of outputs. Okay, now this is y4n. Now we'll see what is the linear combination of input if I apply. x3 is a linear combination, so y3n is the response of the system to the linear combination of input x1n and x2n. So a times x1n plus b times x2n. So here response will be summation x3 n minus k is equal to 0 to k equal to minus infinity to n. But what is x3n? We know that a times response, right? A times x1n and b times x2n. So we can write this summation, it is a times x1n minus k plus b times x2n minus k. This is your x3, straightforward, right? So we got this, and we can say that by observing this is let us say y3. So y3, if you split this and take a outside, b outside, out summation, right? Write two summations for this term and take a out, take b out, whatever you are getting, that is equivalent to y4. Hence y3 and y4, they are matching. Then we can say that the given system is linear. So here if input is 0, let us see, input is 0 means x of n minus k, all n minus k, x of n is 0, the output is 0. That way the candidate, it is a candidate for linear system, right? So linearity, it is nothing but yn is nothing but it is an accumulator system. It is adding all samples up to the present samples and storing the sum in yn, right? So it is like accumulator adding the sample to the previous result, adding the new sample to the previous result. So this system is accumulator system, and this accumulator system we can say, or this what is this? This is actually we are taking samples and adding those samples. Okay, addition of samples, and we are taking the different inputs, we are adding those inputs, passing through a system. So we know that it is satisfying that property.